In this video, we're going to look at cross-site request forgery protection. We'll be explaining what cross-site request forgery is. We'll be looking at the example that you can see in front of you, and then we'll actually be building the class that will allow us to generate tokens and send them with our request. Now, this all sounds a little complicated if you're new to the idea of cross-site request forgery, but like I said, we'll be explaining how this is with this small example. So you can see at the moment we have a representation of perhaps adding the quantity of an item to a shopping cart. Now, this functionality doesn't actually work, so don't worry too much about what this is actually doing. Don't worry about validation or actually adding this product to a cart. That's not the point here. The point is that we're going to be protecting against cross-site request forgery. So what is cross-site request forgery? Well, if we take a look at the source of this form, we have a method of post here. We have a field here which allows us to enter a particular quantity, so assuming numerical, but this doesn't really matter in this example. We've got a submit button, and we have a hidden field here which represents the product ID. We've also got this token, but we'll explain that in just a moment. So what's happening here is when I go ahead and submit this, I go ahead and type in a number, say 1, I click order, and we get this response here, process order. So everything there has been successful. Now, what happens if I go ahead and change this form to a get method, so using the super global get in PHP? Well, let's just go ahead and replace this. So we'll do a find and replace on $_post, and we'll replace this with get. So let's go ahead and replace all. So let's change the method of this form to get, and we'll go ahead and refresh. Okay, so what's going to happen now is when we click or type in 1 and click order, you'll see that the same thing happens, process order, but we have these variables in the URL bar as you'd expect. Now, ignoring this token for now, if we were not to have implemented the protection that we can see in the form at the moment, we would have the ability to pass the quantity that we wanted to place an order for and the product ID as well. So let's just say I was an attacker and I wanted to allow someone to basically purchase something or order something without them knowing. So perhaps they're logged into this website and an attacker knows that they're logged into the website, or perhaps doesn't, and forces the user to view this URL or essentially make a request to the server with these variables, if you like. Now, this could be something like a redirect. It could be, for example, a JavaScript redirect. It could be embedded in an image, which would then load the resource and still make the same request. So if this, you imagine, is embedded in the source of an image, it would do exactly the same thing. However this happens, when we hit enter now, this isn't going to work, but that would process an order for a user. So if, for example, we were to remove what we've already implemented, this would go ahead and it would place an order for a user. So if I redirected you to this page and you were logged in, this would execute the same functionality as if you had submitted the form yourself. So the essence of this is that an attacker can almost make you submit a form. That's probably the basic way of putting it. So we want to protect against this. So what we really need is some way of the user that's visiting the page to actually submit a token along with their request. Now, you saw the token in the URL bar a moment ago. That was because we've generated a token and we've stored this on the server. So we've stored this as a session, a PHP session, and then we have checked the token that's submitted by the user with the token that's been stored in that session. So what's going to happen is I'm going to land on this page, and inside of the form you'll see that I generate a token as a hidden field. Now, this is a random token, it's randomly generated, so if I hit F5 on my keyboard, you can see that this token changes every time. Now, really, it depends on the strength or the actual randomness of this token. We're using OpenSSL and OpenSSL function to generate this. We'll look into that in a moment. But basically, you want the ability to generate the most random token you can. So as long as we've generated a sufficiently random token, what we'll actually do is we'll store this token every time we refresh the page inside a session, which an attacker will not have access to. Then when we submit the form, the token is sent along with this form, and then we can check it on the PHP side. So on the server side, we can actually check this token. Now, if the tokens match, for example, now if I click order, the tokens have matched and therefore we have a success. Now, what happens if I go ahead and I modify this purposely in the form? So I'm just going to add an A onto the end of this and hit enter. Now what happens when I hit type in 1 and hit order? Nothing happens. So the data is sent, the quantity has sent, the product ID has been sent, the token's been sent, but with this not matching, we have protected against cross-site request forgery. So it's a very, very basic concept, but sometimes it takes a little while to get used to. But by doing this on forms, it could be on any form, but particularly on forms that are susceptible to this kind of attack, we can protect against people basically having things done on their behalf by an attacker. So what we're going to go ahead and do is we're going to go ahead and write a class for this, which makes it super easy to go ahead and generate a token and actually check that token on the server side.